As the news from Hotspot shows, in modern wars, one of the main roles is given to combat operations in the air. Planes rise from airfields, launch rockets, and drop bombs on enemy targets, causing massive destruction and casualties. Sometimes it seems that it is impossible to counter these devastating attacks while on the ground. However, many armies of the world have compact means of effective air defense, which, despite their small size, successfully lay enemy aircraft on the ground. After all, the main thing in military affairs is not size, but accuracy and force of destruction. Today, we will describe how British-made air defense systems work. The first British man-portable surface-to-air missile system designed to destroy helicopters and aircraft at low altitudes was the blowpipe or man-pads, which entered service in 1972. However, the accuracy of blowpipe man-pads turned out to be low. In 1982, during the Falklands conflict, out of 100 rockets fired, only 2 hit the target. It was necessary to change something, and so the story of the creation of the STARStreak HVM began. The development of a new missile started in 1984 with a request from the British Army to designers. The military asked to develop a new air defense missile system. Initially, the British Ministry of Defense hesitated between the projects of 2 companies, Shorts and BAE. BAE proposes Mach 4 rocket called Thunderbolt, and Shorts, or rather Thales Air Defense, introduced a high-speed missile available in several mounting options, such as on a vehicle, on a shoulder, and a pedestal, called STARStreak, which was capable of hitting targets at a distance of up to 4 kilometers. In 1986, it was chosen as the basis for the design and development of a new system. In October 1995, the UK Department of Defense accepted a self-propelled high-velocity missile system, SPHVM, with the commercial name STARStreak, and since 1997, it has been transferred to the military. Now in service with the Royal Armed Forces of Great Britain are several versions of the STARStreak SPHVM. This is a task, air-to-air model which can be installed on a helicopter. This model appeared in service in limited numbers and only for the Royal Air Force. There is a version of STARStreak LML that runs from a light launcher. It contains 3 rockets ready to fire and can be used as a stationary launcher as well as mounted on a light vehicle. There is a STARStreak modification. Man-pads are mounted on combat boats or destroyers. This is a powerful weapon for a close-sea combat. The Thor Multi-Mission System MMS is a 4-missile turret mounted on a Pinzgauer 6x6 all-terrain vehicle chassis and was introduced in 2005. The STARStreak Mark II was successfully demonstrated to the UK Ministry of Defence in March 2008 and is the latest update to the STARStreak man-pads. So how does the STARStreak system work? The multiple launch rocket system uses 3 rockets along with clamping equipment and a standard sighting unit. This way, you are able to quickly hit 3 targets one after the other without having to recharge. The aiming block or sighting unit contains an optical head consisting of a stabilization system, a sight mark injector, and a monocular sight. The target is captured and optically tracked by means of a monocular sight and aiming mark. The STARStreak is transported in a pressurized multiple launcher LML launch tube. This tube is attached to the aiming block for firing. The rocket itself consists of a 2-stage solid rocket engine. There is an initial first-stage engine for the exit of the rocket from the tube, and the second-stage engine of acceleration which just directs the rocket to the target. As the rocket takes off from the TPK, the first-stage engine is turned off. The accelerator booster accelerates the rocket to a high speed so that it has high enough spin to create a centrifugal force that deploys the stabilizers. The accelerator is separated from the rocket after it departs from the TPK at a safe distance from the shooter. In less than a second of flight, the main engine turns on and accelerates the rocket to speeds ranging from Mach 3 to Mach 4. After the main engine is turned off, 3 arrow-shaped spears or javelins are automatically fired at the signal of the velocity pressure sensor. Javelins are guided by a laser beam formed by an aiming unit using 2 laser diodes, one of which scans in horizontal and the other in vertical planes. Thus, one missile divided into 3 projectiles hits 3 separate targets, or one but much larger. Targeting a laser beam that provides accurate target engagement is protected from all known countermeasures. Even new missiles or electronic countermeasures cannot detect projectiles in flight. Firing range is from 300 to 7,000 meters. Warhead weight 900 grams. STARStreak warheads are designed to destroy both heavily armored and light air targets. While penetrating the target, the projectiles deal significant kinetic energy damage, and each charge also has a fragmentation warhead that detonates inside the target to maximize damage. The impact of the warhead is very accurate and the error is minimized. These are technical details. So how did STARStreak perform in combat? Countries where man-pads are in service: Great Britain, Ukraine, South Africa, Thailand, Malaysia, Indonesia. However, it is not possible to find confirmed information that these weapons were used by the armies of these states. It is known that in the run-up to the London 2012 Summer Olympics, the STARStreak have been installed on the rooftops of residential buildings near the Olympic Park to ensure the event is safe from a potential air attack. It is also known that since the beginning of the Russian invasion of Ukraine on February 24, 2022, the British government has sent at least 10,000 missiles to Ukrainian forces, including STARStreak, which have seriously hampered Russian air operations. The video on social media shows how a helicopter, apparently in the Luhansk region of Ukraine, is shot down by a missile. Experts say that evidently this is the result of the work of the STARStreak. It is also unknown which modification of the set was handed over to the Ukrainian military. We hope that in the future, the military will lift the veil of secrecy and tell us more about the work of modern air defense systems in real combat conditions.